And I'm
Yeah,
not
it does
well built
get
to
cold.
resist the cold anymore.
That's true. That is true.
So you ready for
And,
class to start?
I'm
Ready for
pleased,
class to start? Go ahead, Daniel.
I said I'm pleased. I have my smile back this week. I lost, and as you know, I lost 4 teeth because of COVID. Couldn't get dental
Wow.
care for almost 2 years, and I got 2 of them back, so I no longer have a gap in my smile.
Why did you lose teeth because of COVID?
I've had bad teeth all my life because of illnesses as a child,
okay.
and I have to have dental care about every 6 months. And I saw the dentist in Christmas of 19, and then not again until June or July of 21. And
he
by
said
that
open
time,
wide.
it was just I had 4 teeth that were just too far gone to save now.
Are they all back in the back molars or?
No, 2 were up front. If you look at the last couple of videos, I would smile and there would be a gap. Which, but now I have a prosthetic. So anyway, so I'm not trying to smile like this anymore. So I'm happy with that. So that's the good news from my house. It's kind of old guy good news, but there you go.
Old guy, good news.
Well, yeah. Between the time it takes a couple of months if you're going to get a tooth removed and a partial.
Yeah.
Whole process is I got 2 removed up here. It takes about 2 months, 2.5, 3 months, because they have to let everything heal.
Right.
And then when it's healed, they can finally take a mold and make the prosthetic. So, yoo-hoo. I did get 1 implant, a lower molar, but that's hella expensive. I started that process last year, Thanksgiving, and I hope to have it done by this year, October. So it takes a year. It's just crazy, stupid slow.
Yeah, I don't know if it's really that, I mean, ultimately that slow, but
Well,
they do take their time.
I'm sure part of it is COVID because they're not taking as many appointments now.
True.
And because it's a lower molar and there's a lot of chewing force on it, they have to make sure the bone is completely healed around the post. And the last time I went, which was June, he said, no, let's give it another month. Okay.
Okay.
And so I'm going to see him again next week. Or is it this week? Anyway, they're going to do a torque test where they put a wrench on the bolt and see if they can move it. And if they can't,
Video.
yeah, pictures sure it didn't happen.
We want video of this. Absolutely.
Doc with his gob way open and a wrench in it.
Oh yeah. Oh
yeah. It's a screw that they put in. It's like a carriage bolt, right? It's a thread on the bottom, smooth on the top, and then it has a head so you can put the wrench on it.
What's up for August? Prime time for the Perseids. Jupiter and Saturn at opposition, and why the 3rd moon of the season is kind of special. August brings the best-known meteor shower of the year, the Perseids. This annual meteor shower happens each year as Earth crosses the debris trail of Comet Swift-Tuttle. Most of these meteors are grains of dust up to the size of a pea, and they create fabulous shooting stars as they burn up in Earth's atmosphere. Although Perseids can be seen from mid-July through late August, the most likely time to see any meteors is a couple of days on either side of the peak. This year, the peak falls on the night of August 11th and into the pre-dawn hours of August 12th. Think of that as prime time for the Perseids. Under really dark skies, you could see almost one per minute near the time of maximum activity. This year's peak night for the Perseids benefits from a moon that sets early in the evening, so it won't interfere with the faint meteors. But before it sets that evening, be sure to check out that gorgeous crescent moon in the west after sunset with brilliant planet Venus. To enjoy the Perseid meteor shower, just find a safe, dark location away from bright city lights. Lie down or recline with your feet facing roughly toward the north and look up. The meteors appear to radiate from around the constellation Perseus, but they can streak across the sky anywhere above you. NASA also has a way for you to catch some Perseids online. NASA's Meteor Watch team plans a live stream overnight on August 11th. Visit the link on screen for more details. August is perhaps the best time this year to enjoy viewing Jupiter and Saturn, as both planets reach opposition this month. Opposition is the term for when a planet is on the same side of the solar system as Earth and directly opposite from the Sun. It happens each year as Earth loops around in its orbit, passing by the much slower moving gas giant planets. Around this time, the planet is visible from sunset to sunrise and reaches its highest point in the sky around midnight. Opposition is also near the time when Earth is closest to the planet, so this is when the planet tends to look its biggest and brightest. Now, opposition does technically have a precise moment when the Sun, Earth, and the planet line up, but in practice it's better to think of it as a period of time, usually about a month. For Saturn, opposition takes place this year on August 2nd, and for Jupiter, it's August 19th. For close-up views and discoveries from Jupiter, follow NASA's Juno mission with NASA's Solar System Exploration website and social media. As you're enjoying Jupiter and Saturn during August, watch as the increasingly full moon slides beneath the pair of planets over several days from the 19th to the 22nd. Plus, the full moon on August 22nd is what's known as a seasonal blue moon, as it's the third full moon out of 4 this season, where normally each season there are only 3. This happens every 2.5 to 3 years, or as they say, once in a blue moon. Here are the phases of the moon for August. You can catch up on all of NASA's missions to explore the solar system and beyond at nasa.gov. I'm Preston Dykes from NASA's Jet Propulsion Laboratory, and that's what's up for this month.
Well, hello, everybody. This is Scott Roberts with the Explorer Alliance, and I'm here with Kent Martz and Dr. Daniel Barth. Kent is going to give us kind of a overview of what's going on today with the Explorer Alliance. Normally, we would have Annie do this, and this segment's supposed to be called Art Minutes with Annie, but Annie had to stay home today to take care of her kids. So Ken is sitting in, and Ken, what can we tell members about the Explorer Alliance today? You're muted, Ken.
First, I have to ask Daniel, how many years ago did you pose for that video that launched? Because that looks, that's impressive.
That's not me. That's my doppelganger.
Doppelganger.
Yeah. So I just had to
When
ask.
I go on secret missions, he stays at home and impersonates me.
Very
I
good.
see.
Right.
He's the one that stays at home. You go out and...
Of course. I'm not going to have him have all the fun.
Yeah. Okay, so here we go. How to join the Explorer Alliance. Real simple. You go to explorerscientificusa.com, slide over to Alliance, and go down to membership, and there you are. And I just copied and pasted the link here. But next week we'll have a little bit better directions and maybe even do a how-to video that shows the screen capture. But it's real simple. We have 2 levels of, come on. There we go. 2 membership levels. Legacy, which is free and has limited benefits, and the Platinum level, which costs $99.99. has great benefits, including getting a $100 gift certificate. So that's the gift we give back to you
Yeah.
is your money.
It's also essentially free. So,
Yeah. So
right.
you pay us $99. We send you a penny extra than what you gave us. And it's a gift certificate. It's good for anything on our website. So benefits of paid membership, extended care, no fault coverage. Come on. The appreciation gift, which is giving you your money back. Contests and prizes. We currently have a contest going on. We'll talk about that here in a minute. And we're trying to do, Andy and I are cooking up a couple of other contests that we'll have. Sneak peek with advanced purchase, which we have one going on right now. We'll also talk about that. We've had it before. The Finder foot base, the 2-room pop-up observatory tent, which, when we do these products, we think about, okay, how long is it going to take to sell them all? And we place an order to fill, that what we project. It turns out the 2-room observatory tent was significantly more popular, and those should be getting shipped here this week or next. So we're probably 30 to 40 days out from those getting back in stock. So we'll might have a little celebration and when those actually show back up. Free maintenance. If you're an Explorer Alliance Platinum member, you send in your telescope or eyepiece or focuser, and we perform the maintenance for free. It also comes with advanced replacement, and I'm trying to be clear when available. If you send in a ED80, an 80 millimeter essential series or FCD 100 telescope, we cannot send you an advanced replacement because we don't have any to send. So, we can't do that when we don't have anything to send.
That's a temporary thing at this point, but
yeah, temporary thing at this point, and VIP access to events. So we do all sorts of Explore Scientific sponsored events that are our events. So we do have some events that we're associated with, but you don't get VIP access to those events because those aren't events we're putting on. We'll see a few of those here in a minute as well. All right, so the current advanced purchase is the Explore Scientific Bino Viewer. And I don't know how I set it up to do this, but it's pretty cool, except I have to click every time. We want to be clear on talking about these. These are designed for wide field, low power use. So at high power, these are not designed for. Like if you're trying to split double stars
or something like that.
Yeah, something like that. Right. It's not going to work.
It's Bino viewers are just not the thing to use for that. But
right, even though you might want to try and see the separation in 3D, you're not going to with this. But the moon, nebulae, M31, things like that are going to look spectacular in this. So low power, wide field stuff is where this is going. It's available only for EA Platinum members. So in other words, if you're a paid member, you have access to buy this, and this is the only way you can buy it. This is not.
So Space Time with Robert says, so no planetary for binos. That's not true. Okay. It just means at the highest magnification, it's not that great. Okay. Because of the prism and mirror arrangements that's in there. Okay. So that's the deal.
Daniel, what did you say?
I said it's not optimized for high power.
It's not optimized for it.
Right. No, and your high power challenges your equipment because there's a lot less light throughput, and then the Bino viewer reduces that as well. And so your image brightness and resolution both degrade at higher power. It's just get an eye patch if you want a 300.
That's right.
Get an eye patch and use one eye. You'll get a lot better view.
Right. I can tell you that looking at the moon, the Ring Nebula, was fantastic.
Oh,
We
looking
looked-
at this, we used a solar filter and looked at the sun. It was amazing.
yeah,
You
it
know,
was
so yeah.
fantastic.
Yep.
All right. So also, this package comes with 2 argon purged waterproof 52-degree 25-millimeter eyepieces shown here in the picture that we have tested out and had great success with. I'm not sure. I've not gone through the whole range of inch and
The
quarter
thing that's so
eyepieces.
cool about this Bino viewer is that it doesn't require any special extension tubes to work. Okay. It also has 2 ring lock systems so that you don't have set screws to lose. You put in the eyepiece, you twist the golden ring lock on there, and it holds the eyepieces very securely.
And it also, because of the way it's designed, centers them up. So when you have that 2 screw system, or 3 screws, you can get it offset.
Right.
And
That's true.
yeah, these have a diopter. You can see there in the picture for the right eyepiece, or what I see as the right eyepiece. It's on the left in the picture. So you can focus the telescope using your left eye, and then cover up your left eye or close your left eye and adjust the diopter for your right eye so you can get both eyes in focus. Very cool. Then limited availability. We've got a very limited number of these that we've had a production run. And it's get them while you can get them. And
Right.
this goes slow. I've got to speed up this transition. $499. What's going to cost you? $500. If you bought the pieces separately, it'd be $680 to get them. So that is a fantastic deal. And we're selling some, and we want to sell more. So everybody needs to get out there. And how do you buy them? Real simple and straightforward. You email, and Scott, go ahead, and there he goes. Explore Alliance at explorescientific.com. And anything that's Explore Alliance related, whether you want to ask a question, you want to make a purchase or find out what deals are going on, you want to enter a contest, that's the email address to use. So have a current purchase going on as well. The Explore Scientific 3D etched crystal cube. It's a beautiful laser etch. They focus 2 lasers together where the beams collide is how they etch that in there, as Scott explained it to me. I think it's very, it's very cool to look at. Again, exclusive for EA members. We've got like 4 left, I think now. It contains an image of the Explore Scientific ED-152 telescope and a barred spiral galaxy hovering above it. They took, and this is on a G11, it looks like. There's that Titan. What mounts that on, Scott?
No, this is was a prototype mount that we have not come out with. So
Okay.
when we did design, but I'll tell you this, although the galaxy's not to scale, okay, the telescope is, and it was made from the CAD drawings of the ED-152, which is very, very cool. And being that it's translucent, you can see the optics on the inside. You can see the finder bracket. It's the right angle 8x50 polar illuminated finder scope that we use on it. So it's exact in every respect, and so that's kind of cool. I like that.
Yeah, it's a very cool looking piece, and it's great for desks, mantles, and bookcases. Anywhere else, it's sort of a paperweight, but it's really not a paperweight. I see it as something more of an art piece. But certainly, if you've got an astronomer in your life, it would make a great gift to yourself, basically for Christmas or birthday, or drop some hints to your significant other to purchase this for you. Again, it's a limited supply.
There's 4 left, right?
I think there's 4 left.
Okay.
So $59.99, which is a $100 value for, that'd be 40% off. Again, how do you get it? You use the secret decoder ring, that comes in your cereal box. to figure out the email address is explorealliance@explorescientific.com. As we said, this is something you're going to use. That's email. It's just become embedded for your EA membership. So current contest, we have galaxies. It's open to any company's gear. Some of our contests, you had to have, an Explore Scientific mount or telescope or something. This is open to any
or a
gear.
special camera, or we did a smartphone astrophotography contest. This is a truly wide open. So
All right. So entries have been sort of slower coming in. I think people are, for some reason, hesitant to. They don't think their work's any good. Enter your work. We want to see your work and highlight your work. All of the entries we get will be published in the next Skies Up magazine. Entry deadline is August 15, a few days away, 2021. Winners, first place receives $75 ES gift card. Second place, a $50 gift card. Third place, a $25 gift card. And all three winners receive an EA membership upgrade or extension, because you don't have to be a paid member to enter this contest. But if you win first, second, or third, you're going to go from a legacy to a platinum membership. We're just going to give it to you. And with that comes the special gift. So without any money, you're going to get a $100 gift certificate back if you're a legacy member and enter the contest and win first, second, or third place. And everybody that wins first, second, or third is going to get an 18 by 24 print suitable for framing. So that's way cool. Galaxies. You've got a week and a few days left. Get those into us so you can get in and get some swag. So current events. What's coming up? September 10 and 11 here in Northwest Arkansas, Stars and Sauce. It's a music festival with an astronomy theme. And they're really pushing the astronomy theme. Tyler and I are working on a list of the telescopes we're going to bring and what those telescopes are good for. So they're really doing some great outreach and pushing the telescopes. And it's on a farm near Eureka Springs. It's called The Farm. More details at www.starsandsauce.com. Starsandsauce.com. If you're an EA member and show up, we'll give you a big non-COVID hug or something. Might buy you a drink or something. Who knows? Okay, October 1 and 2 in Gilbert, Arkansas. The Arkansas Dark Sky Festival along the Buffalo National River, which is an international dark sky park. I should have done this in a bit.ly link, but if you go to darkskyarkansas.org, you'll find the link to it. It's October 1 and 2 in Gilbert. A really nice dark site, probably the darkest site with any kind of good public access you can get in Arkansas. And it's going to be nice.
Down to like Bortle 2 or Bortle 1 skies. It's about as dark as it gets.
It's about as dark as you can get. It is as dark as you can get in Arkansas, unless you get out in the national forest south of the Buffalo River. But there's just nothing out there. There's no roads, hardly anything. And so it becomes, this has got great access. Gilbert is a paved road, and it's a mile off of a U.S. highway. So easy access, going to be a good time. And here we go. In 2022, we're going to have Winter Star Party. I did look up the dates. Started to and got sidetracked with another question. But the Winter Star Party, we're going to go to that. NEAF, the Northeast Astronomical Forum in April. We'll be attending that. There's some other star parties Scott and I have talked about that I didn't put down here until we get them confirmed. And he says, yeah, we're going. Don't want to put them on here. But Mount Wilson is now up active on the website, July 17 through 19, 2022. Scott, you want to talk about this just real quick?
Yeah, the Mount Wilson event, in fact, I don't think it's going to be in July. I'm not sure why July's down there, but we'll check into that.
Okay.
Anyways, What we will do for the Mount Wilson event, we've done this once or twice before, where we go and use the 60-inch telescope at Mount Wilson for an evening. So your evening's going to start off with people will arrive probably Thursday afternoon in the Los Angeles area. Two good places to fly in. One would be LAX. The other one would be Ontario Airport, which is also very close to Pasadena. That morning, Friday morning, we will go to the Jet Propulsion Laboratory, and we will tour the facilities and check out what they're doing in, planetary space flight. And then that evening, Friday evening, we go to Mount Wilson itself and use the 60-inch telescope for that night. We have Saturday as a backup night. And then, in case it gets clouded out, that has happened before. It's not likely, but it does happen. And then on Sunday, we plan to use the historic SNO telescope and get a demonstration of how solar astronomy was done back in the day when George Ellery Hale, set up that whole facility. The SNO telescope still works. The spectrograph still works. It's cool. It's historic. You're going to be surrounded by, history and knowing that you were in the same places that Albert Einstein visited. Hubble. Think of all your physics and astronomy heroes. They were at Mount Wilson at one time or another. So. Including some historic women astronomers as well. So that's going to be fantastic. Then we have the Arizona Dark Sky Star Party.
Yeah, let me go to that slide. But real quick, Scott, the Mount Wilson Star Party has very limited capacity. It's not like
25
yeah.
can go. That's it.
Right.
Yeah. So when we open it up for real, it fills so fast, that, think about it, get ready, and we will announce it on one of these shows when we do put it up live and give you a shot at it. So, and then we've got the David H. Levy Arizona Dark Sky Star Party. That's being planned for September. That's late September, and that'll be really cool. Another event that's in the beginning of September is in another country. This is in Armenia, in a city called Yerevan, and we will be attending a music astronomy festival on a grand scale. They're expected to have tens of thousands of people there, and this is called Starmus. So you can, I'll put in the link here. But we have been invited to give the star parties at this event. So people that you might see at Starmus would be Brian May from Queen, Peter Gabriel, other rock stars go to this thing, and then the rock stars of physics and astronomy show up for this thing as well. So this particular event is really cool because they're opening it up more to the general public. And so tickets for Starmus used to be very expensive. Now you can get a ticket, I think it's for a couple of $100, something like that. And, see concerts and rub elbows with some very interesting people, to say the least. So, and then we have, and we have more things that we're planning. So it's going to be very cool.
We're working on the Eclipse Site Star Party. Going to start nailing down details of that, and hopefully have some announcement coming in a couple of weeks for that, which is going to be in April of 2022. So we're talking about that as well.
Yeah.
And so that's going to be on the horizon as well. So we also have a current prize opportunity in honor of Dr. Daniel Barr's 20th episode of How Do You Know? We're giving away an argon purged, waterproof, 52 degree, 20 millimeter eyepiece later in this show. Daniel's going to ask a question. I don't know what happened.
You're at the end of your slideshow.
There we go. Daniel asked a question. All correct answers will be entered into a drawing for the eyepiece. It's $119.99. And once again, use your secret decoder ring to find out the email address for the prize to enter send your answers, is exploreralliance@explorerscientific.com. So you got to use your decoder ring to figure that out. So that's the end of the ARC Minutes with Kent, who is pinch hitting for Annie. Hopefully she'll be back on the desk tomorrow, or her kiddo will be feeling better and she can get back on the desk. But family comes first, and we're glad she's able to take care of that young man. I think he's 4. Anyway, that's the end of what I got. So
Great. Okay.
Yep.
All right. So there was a little question. Would the Bino viewer work on a Newtonian telescope? And the answer is yes, because it doesn't need any more focus travel than a regular eyepiece would. So that's the deal. Okay. So we're going to transition to Dr. Barth. Anything else you wanted to add, Kent, before we go?
No, I'm going to stay on. I think I'm sort of caught up. I can continue to do a little work and listen and maybe ask a question every once in a while. So.
Okay. Well, we have a really interesting featurette that touches on some of the points that Dr. Barth is going to make today. But if you haven't done this already, you can go to the How Do You Know page on explorescientific.com, and you can download Daniel Barth's free ebook called Astronomy for Educators. And then you can also just get the study guide for today's program, which is, Mars, the dying planet. So here we go.
For thousands of years it was only a red point in the sky, a nameless denizen of the trackless night. When the Egyptians settled their civilization, it had become familiar enough to receive a name, Hadesher, the Red One. The Greeks associated it with bloodshed and the war god, Ares, and so also did the Romans, giving it the name of their god of war, Mars. Over the intervening centuries, interest in the red planet has increased more and more. It changed in people's eyes from a planet full of fears to a source of intrigue and fascination. It became known to be the only planet in the solar system on which there was a strong possibility of finding life, past or perhaps present. Astronomers like Galileo, Huygens, and Kepler, who first calculated the distance between Earth and Mars, are just a few names that we have to remember. The second half of the 20th century saw a new era in Mars exploration. After a series of failures, the first spacecraft to make a flyby was the Soviet satellite Mars 1 in 1962. Since then, both the United States and the Soviet Union launched many different spacecraft to the red planet. In 1964, NASA's Mariner 4 was the first spacecraft to send 22 detailed pictures of Mars, while passing at about 10,000 kilometers above the planet's surface. The most important finding of the mission was that the atmospheric pressure was between 4 and 7 millibar, based on data from a radio occultation experiment. 3 years later, contact with the probe was lost. In the following years, different Mars and Mariner missions were sent to the red planet, offering more and more accurate pictures and data on the Martian surface and atmosphere. The 1970s were the decade of the Viking space probes. Viking 1 and 2 were the first robotic spacecraft to land on Mars. The Vikings were sent on a mission in 1975 to determine whether life had ever existed in any primitive biological form on the red planet. Scientific evidence by then strongly suggested that Mars had once been a planet with flowing rivers and a denser atmosphere. Only by direct sampling of the soil and atmosphere could the scientific community formulate a reasonable explanation for its evolutionary past and present state. Is there water on Mars? This was always the main question scientists tried to answer. NASA thought it had answered the question. The majority of the experiments on Mars at that time indicated no biological activity. The one apparently positive result was later interpreted as a non-biological chemical reaction. During a quiet period in the space exploration of Mars, laboratory studies of the planet on Earth received an unexpected boost when it was found we already had rocks from Mars here. From the age of the various meteorites found, we know that water was around almost certainly 1.3 billion years ago. But still, uncertainty remains. The influence of the Earth's environment on these samples could have changed some parameters of the rocks. So the Martian adventure continued. In 1996, NASA sent out the Mars Pathfinder. The mission was primarily an engineering mission, demonstrating technologies and concepts for eventual use in future missions. But Pathfinder also delivered spectacular images around the landing site, and science instruments investigated the structure of the Martian atmosphere, weather, and geology. During the same year, European scientists were involved in the Russian Mars 96 mission. But due to a malfunction in the third stage of the rocket, the spacecraft re-entered the Earth's atmosphere and fell into the Pacific. Flying on ESA's Mars Express mission, most of the European instruments on board of Mars 96 have now a new chance to get to the red planet. In June 2003, Mars Express will set off on its 6-month journey from the Baikonur launch pad in Kazakhstan on board a Soyuz frigate launcher. With an expected lifetime of at least 2 Earth years, almost equal to 1 Martian year, Mars Express is one of the most cost-effective ESA missions ever built, and it was developed in an incredibly short time. The spacecraft will also carry a lander called Beagle 2 that will head for the Martian surface, in addition to 7 other instruments on board of the orbiter, all of which will make a contribution to solving the mystery of water and life on the red planet. One thing is for certain: Mars Express will not be the last European mission going to the red planet. In the way that science fiction often becomes reality, Mars is now a prime candidate for future manned exploration, and even
Well, we're back. Hope you found that to be informative. It was fun today, Daniel, to read up more about Mars, and I'd known about Schiaparelli or however his name is pronounced. I think it's pronounced a couple of different ways, and added strength to Percival Lowell's already formed convictions, that life, intelligent life, not just life, but intelligent life was on the red planet. And so it's easy to understand how he might have arrived at that conclusion, but, certainly he was not following a process of science, Nevertheless, Percival Lowell's influence in the world of astronomy is still being felt today. Lowell Observatory is still a thriving institution that is involved in serious research. And, I don't think the guy was crazy, but certainly was in love with the idea of intelligent beings being on the red planet. So, but I'll let you take it from here.
Thanks,
Thank
Scott.
you. Thank you.
Friends, we're going to be having a series of 4 programs on Mars, and we're really focusing on the search for life on Mars. We're going to take you up through various stages of this. Today, we're going to take a look at the history of exploration of Mars from the Earth. And Mars, as everybody knows, it's one of the 5 classical planets that you can see without a telescope. You can see Mercury, Venus, Mars, Jupiter, and Saturn. Those are the 5 classical planets of the Egyptians, the Greeks, all the ancient civilizations. And Mars is kind of peculiar. And once again, I'm going to share one of my quality diagrams with everybody here. So we'll take a look at this. And this is kind of gives you an idea when we talk about opposition and conjunction. We've talked about this before, Scott. Mars is a very ancient, or excuse me, astronomy is an ancient science because humanity's been practicing science for many millennia. And more or less, modern era of astronomy stretches back over 2,000 years. So we have a lot of legacy ideas. A lot of legacy ideas come to us from astrology. I know that's kind of a naughty word in science, but astrology was kind of the paywall for serious mathematical astronomical work from very ancient times up through Galileo's time. If you wanted to get paid to do math and science, astronomy and space science, what you really did for a living is you did astrology. And astrology required you to do these forecasts and horoscopes and predict the future and all this sort of stuff, which doesn't work. But for people who believed in it and wanted to pay for it, it provided a way for you to get funded. And all sorts of people that are quite famous participated in this. Kepler did it, Tycho Brahe did it, Copernicus did it, Galileo did it to some extent. And so all these people participating in this stuff. And so we get these ideas, oh, it's important when Mars is in opposition or conjunction, astrologically speaking. What we're talking about here with conjunction, this is an alignment between the sun and Mars. Mars is not visible in the sky at conjunction. It passes very near to the sun, the earth, the moon, the earth, the sun, and Mars are lined up. Opposition is different. Mars is, and people think opposition, it must be far away, but in fact, opposition is Mars' closest approach to Earth. And here by opposition, we mean that in our sky, the sun is on one side, Mars is on the other. At opposition, as you can see in the diagram here, not only is Mars closest to Earth that it gets during its entire orbit, but Mars rises in the sky at sunset, it stays in the sky all night long, and it sets again at sunrise. So we get the longest possible viewing time of Mars. And when we look at the distance, and you can see in the diagram there, the Earth is 1 AU away, Mars is about 1.5 AU away. So you can get Mars as close as half an AU, which is very, very close, compared to when Mars is on the other side of the sun. Mars is going to be 2.5 to 3 AU away. So we're talking about a change of about 5 times in the relative distance. So Mars can appear up to 5 times larger in the sky. Now for the naked eye, what happens is Mars appears brighter. You're looking at a light source that's closer to you. It appears brighter, just as an oncoming headlight for a car does. And but in a telescope, Mars actually gets close enough that we can see significant surface features. Remember, Mars is a small world, half the size of Earth, about twice the size of the moon, but at its closest, 50 million miles away, roughly. And so planet half the size of Earth from that far away, we can see stuff on the surface of Jupiter and Saturn because they're enormous worlds. Jupiter is 12 times the diameter of the Earth. Saturn is 10 times the diameter. So it's much easier for us to see the surface features. Mars opposition, which happens about every 25 months, is the time. There's also another interesting feature with Mars. And when we talk about the difference of Martian, see if I can blow this up a little bit. There we go. When we talk about Mars orbit, Mars is much more elliptical in its orbit than the Earth is, than most of the planets are. Mars has a rather highly elliptical orbit. And this has many impacts for Mars geophysically, but in terms of Earth, realize Mars takes, the oppositions occur about every 25 months. This means that we don't see Mars at the same point in its orbit every opposition. And so we have some oppositions where Mars is at aphelion. It's far away from the sun. And we have others where Mars is at perihelion. It's as close as it's going to get to the sun. And so when we talk about, and I think I've actually drawn a conjunction here, not an opposition. My bad, kids. I'm looking at this and going, anyway, it's a live show, isn't it? So, but you get the idea that Mars changes distance from the sun. What it amounts to is about every 15 years, we get a really favorable opposition. We last had a really nice opposition in 2018. And so what's going to happen over the next 3 oppositions, it's going to be lower and lower quality, and then it'll gradually start to improve again. So we're in kind of the valley of the Mars opposition cycles right now. This opposition coming up is going to be pretty good, but the next few years are going to be less so. So if you want to get your Mars viewing in, kids, plan on doing your Mars viewing coming up. In any case, when we talk about these things, these opposition views, it turns out that the year 1877 was a really significant year for Mars observational science. And there's a couple of things going on here. By 1877, glass making is reaching what we would consider to be a modern era. Mm-hmm. We know how to make different kinds of glass. We know how to make multi-element objectives. And you realize that when Newton invented the reflector, arguably the smartest human being who's ever walked the earth, when Newton invented the reflector, he basically said, refractors stink. At that time, we were talking single element objectives. And whenever you have light refracting through a lens, it acts like a prism. Different colors come to focus at different points. So something like Mars or a star, no matter how you focus, has these funny halos, sometimes red, sometimes blue, what we call chromatic aberration. And Newton said, you'll never solve this problem. When the smartest man in the world says it's impossible, a lot of people quit trying. And so research on refractors just died for about a century and a half. It was only later Fraunhofer and others started experimenting with different, they had this idea, gee, what if we put 2 lenses, different kinds of glass, and we get the modern 2-element air-spaced achromat. And what this means no color. It's not quite true, but use different kinds of glass with different indices of refraction, and you can get more of the spectrum to focus at one place. What they did before this, in the early 1800s, late 1700s, Scott, the way to fight chromatic aberration was to have a really long focal length.
Mm-hmm. That's
We're
right.
talking about telescopes with 30, 40, 50 foot and more focal length.
Crazy focal length.
You kind of say, how the heck do you do that? What they did, Scott, was they would mount one lens on a building in a holder. Then they would get on the ground with an eyepiece, and they would position it basically on a tripod so they were lined up. And of course, you couldn't point this thing anywhere. You
Right.
could just get it aligned and, at
Let
this
stuff float
time,
through the
Mars will
eyepiece.
pass through the field of view. And so,
Didn't Fraunhofer made one, I think, that he
oh, yes.
hung from a platform, and then there was no tube to
No
it.
tube. Oh, absolutely
No
not.
tube. Yeah. Oh, you
No
wanted
tube.
a
Yeah,
tube.
you're literally
Right.
talking about an objective.
Yeah, back when you
mounted
bought
to a
telescopes
building.
back then, you had to order the tube separately.
Oh, yeah. And a lot of times with these long focal lengths, you couldn't make a tube that was rigid enough
That's true.
or strong enough.
That's
it
true.
would flex.
It flex. That's
It would be
right.
no good. So you took advantage of no light pollution because we're before the electric light era.
Yeah.
And
Thank
people
God
would
for
go,
Isaac Newton. Thank
Yes.
God for Isaac Newton.
people would go out and these crazy long focal lengths. And you're talking F50, F100. It's just insane, some of the crazy long focal lengths.
Right.
Enter modern glassmaking in the 1840s, 50s, and you start to get quality objectives where now you can make a telescope with f15, f12 focal ratio, where you can build a tube, usually out of metal. You're talking, some were wooden, but a lot of times you're talking iron tubes, massive instruments, but they were rigid, they were strong. You could put them, Fraunhofer develops his German equatorial mount, counterbalanced on either side, the telescope on one side, the counterweight on the other. The tube is balanced, so now you have a precisely balanced instrument. It tracks the sky. This is a major thing. And now you have instruments and you're starting to make objectives of 5, 6, 8, 10 inches. And the telescope that was used by Schiaparelli in 1877, an 8.5-inch refractor. I have a 5.5-inch, and it's an f12. My big refractor, I kind of feel a connection to the historical. I have, I think, a lot better glass than he had, but nevertheless, it's a comparable instrument. It's a great big instrument. It needs a big, powerful mount. But Schiaparelli was making some of the first maps of Mars and Mercury. And in 1877, with these better quality refractors and permanent observatories, they're confirming the rotational period of Mercury. They are going ahead and confirming the rotational period of just over 24 hours for Mars, which sparked, this is very Earth-like. And the axial tilt is very Earth-like. Again, Mars day is within about half an hour of Earth's. It's a little longer. Its axial tilt is very close to Earth's, within a couple of degrees. And so you get this, wow, this place really looks Earth-like. And so Schiaparelli is going ahead and doing this opposition. And what he's looking at prior to this, the best drawing of Mars, and again, I'll go ahead and share this with everybody. This best drawing of Mars, this was made by Christian Huygens, the Danish astronomer. He is a contemporary of Newton, late 1600s, so he's a 17th century observer. And here's his pencil sketch that he recorded. And basically, this is the first time anybody has gone ahead, looked at another planet, and seen surface features. Now, yes, cloud bands had been recorded on Jupiter, and we found Saturn had rings. But in terms of actual surface features, and we know now there's a difference between terrestrial planets and Jovian planets, but this is the first time, and it's not a lot of detail. But he's using a handmade, he had a couple of telescopes, a 4.5 and a 6-inch reflector. So those of you out there with 6-inch Dobbs, you're following in the footsteps of Huygens. And so we're looking at this, and Schiaparelli brings to bear for the first time in 1877 a modern instrument. This is a refractor with a multi-element objective. Very little in the way of chromatic aberration. It's truly a modern instrument. And it's an 8.5-inch refractor. It's massive. I think it's a f12 or 13. It's a great big monster of a scope. And Schiaparelli comes in and he's seeing surface features. Now, we know that when we're talking about surface features on Mars, there are features which are linear or line-like. I don't want to say linear, I don't want to distort it, but Schiaparelli is looking and he's seeing features separated, dark and light, separated by what appear to be what he called canali. And he's looking at this, and the English-speaking press picks this up. Famous Italian astronomer discovers canals on Mars.
Canals.
Canals. Canali?
Not canali. Canals.
They mistranslated the term. They said canals. And basically, Schiaparelli's not talking about canals. He has nothing to do with the idea of an active aquifer on Mars. The more he protests and says, no, you've got it wrong. Not canals, canali. Oh, famous Italian astronomer confirms canals on Mars. And it's just like today. If it sells, if it bleeds, it leads. If it sells, then we can misquote you and we can sell more papers. And so kind of we would call it the tabloid press today, I guess, picks this up and they run with this, and it becomes an international sensation. The idea of canals on Mars. And of course, from the idea of canals on Mars, we take a singular fact. We have line-like features separating light and dark areas on the surface of Mars that have been recorded. And remember, no photographs. This is really, there's no photographic technology at this time.
Technical drawing was the...
Technical drawing, sketching at the eyepiece.
Yep.
There's film at this time. 1877, we know we had photographs. I've heard this, well, there was photographs of Abe Lincoln in 1862, but that film was glass plates. It was really slow. If you've seen any of Dramatize, the photographer gets under the hood, right? And he reaches around to the lens cap and says, okay, everybody take a breath, hold it. And he counts to 10, and then he puts the lens cap back on. And that's why these photographs from the 1860s and 70s are people looking very wooden, because they had to stay up. They didn't have.
Well, they had braces to actually hold their heads.
Sometimes for portraits, yes, they did. They had little. Matthew Brady did this with Lincoln one time, and he refused to ever do it again. They had a head clamp, like you were going to do brain surgery. They would clamp your head, and it's still done today. It's still done today. There's a couple of famous examples. We won't go into that, but suffice it to say that in 1877, there is no photographic technology, number one, sufficiently fast film to make these exposures, and number two, the tracking technology was not satisfactory. Today, we talk about astrophotography. Well, I'm stacking. This is 265 stacked images. And what are you doing? Well, you don't care about tracking as long as it's reasonable. You're taking 15-second exposures or 10-second or 5-second exposures of Saturn, and you take 1,000 of them, you pick the best 700, and the computer aligns them and stacks. There's no such a thing. This is old school. If you wanted to get a photograph of Mars, and remember the light coming through the eyepiece, far dimmer than natural light. Sure. And so you would have to track Mars for a couple of hours. First of all, Mars rotates in that time. Secondly, the tracking technology was not satisfactory. They were talking mechanical tracking, like a wind-up cuckoo clock, and they did have that. And you're talking a gravity weight driven mechanical tracking system, and they had those, but obviously you're getting the tick tock induces vibration from the release mechanism, the escapement. And so there's no photographs. You draw at the eyepiece. So these drawings come out. People are fascinated. it sparks a worldwide surge of interest in Mars exploration, which at that time meant Mars observation. There's a huge boom in business. Alvin Clark and Sons, their telescope business booms during this event. Telescope manufacturers, philanthropists at this time are persuaded to help build observatories. And there's kind of an arms race between America and Europe at the time of who can build the biggest telescope, who can have the most observatories going. And so it's a grand period for astronomy. And Schiaparelli is sitting there in the background, and he's almost weeping and pounding his table, tearing his hair. And I didn't say canals, but nobody's listening. Nobody's listening because the hypothesis of canals on Mars, which is based on one data point, is so attractive and so beautiful and so wonderful that everybody says, it must be true. And people begin to do the classic thing. They start to twist theories to fit facts they start to twist facts to fit theories rather than theories to fit facts. Arthur Conan Doyle's famous for his quote in Sherlock Holmes, Watson, it's a capital error to theorize in advance of your data. One must adjust theories to fit facts, not twist facts to match up with a beautiful theory. And that's exactly what's happening here. H.G. Wells, the English novelist, is inspired by Schiaparelli and the whole canals on Mars. And this becomes essentially an entire hypothesis that's referred to today as the dying planet. And it kind of runs like this. Well, if there are canals on Mars and they're big enough for us to see, how big must they be? And it
Huge.
turns out these things are like, they're not even like the Suez Canal. You're talking more like the Red Sea. You're talking things that are many tens of miles wide and run for hundreds or thousands of miles over the surface. And so you're like, wow, if we're moving that much water, where's it coming from? Where's it going to? And why are we doing this? You have to keep in mind that at this time, the 1870s, what's going on in Europe? People are just transitioning from canal transportation to railroad transportation. This is the era of the Erie Canal. This is the era of barge and canal transportation in Europe, England, the Low Countries, where they have water. They're building canals and they have walkways along the canals, horse-drawn barges. They're just starting. And so canal engineering is a hot topic. And they're like, oh, if you're moving that much water, where's it coming from? Where's it going to? Well, the only thing that makes any sense is, gee, it has to be going from the poles to the equator. Why? Why would you transport that much water? People must need it. It's a huge civil engineering project. I know Mars is dying and drying out. Telescopic examination at the time. And what are we doing? We're looking at Mars, occult stars. And we're starting to get the idea, gee, the atmosphere is really, really thin. We've talked about this before. Galileo discovered there was no atmosphere on the moon. How did he do it? Watching the moon, occult stars. What happens? The stars go out like someone flipped a switch. Why? No atmosphere on Earth. We see the sun goes down, the sky gets dimmer, the sun gets redder, and we get this attenuation where the sun dims and finally sinks, and then the atmosphere goes dark. On the moon, it's like you cut it off with a knife, which you did. The moon sunk, or the star dropped below a peak on the horizon, and bam, it was gone. Do the same experiment on Mars. We're finding we see some attenuation. The light does dim slightly, but only very, very slightly. And there's no real blurring of the stars before they disappear over the edge. The conclusion, Mars must have a very, very thin atmosphere. If it's a thin atmosphere, and 1877, we're trying to do spectroscopy. It won't come along for a couple decades yet, not significantly, but people are getting the idea Mars must be very dry. That kind of an atmosphere, we know when we go up mountain climbing, the air dehydrates. As the pressure gets lower, the atmosphere's ability to hold water vapor drops. So they get this idea Mars must be drying out. Look, it's this brown ochre color. Kind of looks like the Sahara, don't it? Gee whiz, it must be a dying planet. And so this hypothesis,
But
again,
not dead.
not dead.
Didn't
Oh,
think
no.
it was dead, right?
If it was dead, who would build the canals? Right? And
Right.
so we're saying, the canals are real. It looks like a desert. It's very thin air. That can't hold water. It has to be drying out. And they're transporting now, of course, nobody bothers to think about, gee, what happens to water at that kind of air pressure? And even if we're talking about the kind of air pressure we're talking about at the top of, say, Mount Everest, right? 1/10 of an atmosphere, water evaporates like crazy. And the boiling point with Mars low gravity would be very low. Could you actually transport water this way? No. Well, the canals would have to be glassed over or something crazy. It makes no sense whatsoever on an engineering, but from a romantic perspective, it's a beautiful thing. And people are just in love with this idea. H.G. Wells writes War of the Worlds. Well, if it's a dying planet and you guys next door have lots of water and vegetation, we're going to come kick your ass and take over. And if you've the movie versions of War of the Worlds, the old 1950s one, I think is the best. The modern remake is kind of terrible. The book is absolutely terrifying. The Martians are, I don't know if you would say, are you a cannibal if you eat your neighbor? But they're certainly carnivorous and interested in farming people like cattle. And the book itself is horrible. It's just a horror show. But you get this dying planet, and then we get Percival Lowell. So we'll give everybody a look. And when you talk about, you've seen pictures of those of you who are regular viewers, you've seen pictures of my lovely Appomattox telescope. Here's Percival Lowell at the 24-inch refractor in Arizona on Mars Hill. This is truly an entire step forward. And Percival Lowell had this made for himself. He would be today like an Elon Musk. He was a what would be for the time a billionaire, and he was an international man of high circles. He was a diplomat for a while and a globetrotter, and he came home and he falls in love with Mars. And so I'm going to build myself an observatory. This isn't much different from Bezos and Musk saying, I'm going to space. And I see a lot of criticism about those people. I think envy is such a low emotion. I'm surprised people express it in public. We look at these people doing these things, and you have to ask yourself, how many times has the government made great strides in science, engineering, and tech, and then made them available to the government? About the only really governmental organization that's ever done that is NASA. But generally speaking, entrepreneurs drive the economy and they drive our technology forward. Here's Percival Lowell, and he's not a trained professional. There's a lot of go away, you don't have a degree. But then again, he has the best toy in the world. He has literally a world-beating machine. And he says, you know what? No degree, don't care.
Don't need it.
I have a telescope. This is my degree. And Lowell does a couple of things. He's not only a really good scientist, he is a good scientist with a world-class instrument, but he also is a world-class writer, and he's a promoter, and he knows how to, he would have been a YouTube influencer. He would have been an internet influencer. And he's writing books about Mars and the dying planet. He's writing books that made him more money than any of his other ventures did. His books were they were like Harry Potter, worldwide bestsellers. Huge, huge. And he's got this instrument, and he's releasing drawings, and the scientists are saying, wait for us. Let us have a turn at the eyepiece. And he's like, heck no. You're the people who are criticizing me for no degree. well, let us interpret your data. And he's like, no, I don't need you. I can see, I can draw. And of course, Percival Lowell's drawings, and we've all seen them, they have these lovely features with these very romantic and fanciful names. And we have Edgar Rice Burroughs, who's inspired by Percival Lowell, and he's writing the Barsoom novels, John Carter on Mars, and the whole Martian series. And he incorporates the dying planet. And so H.G. Wells, Edgar Rice Burroughs, and here's all this literature in these books, and everybody's like, oh my God, the public is now telling the scientists, we want you to research Mars. We want you to prove Lowell right. And the scientific community is pushing back and saying, don't tell us what to do. We're the scientists with the degree.
Right.
And yet the people who donate money are saying, oh, well, are you going to look for canals on Mars? I have a big check. And this is very much like science today. Are you going to be researching climate change? I have a big wallet. And you'll be researching this topic, right? And so popular hypotheses, regardless of their fit to facts, are being pushed by people with money, people with influence. Scientists are pushing back. And so during this time, if you're a real astronomer, you work for a university, you have a degree, that sort of thing, if you're a professional scientist interested in astronomy and you're wanting to do research on Mars, people are going, we're not touching you with a stick. Money? Here's a quarter. Call someone who cares. They are not touching that. And so there's a great deal of antipathy in the scientific community about this man with his telescope that we all would love to have one like that, but he won't even let us in the room. And then Percival Lowell beats them to the punch again. And as we have learned from Elon Musk and Jeff Bezos, and yes, I have, I'm not saying that I'm a fanboy of these fellows, but you know what? Winning is sexy. It is. And there's nothing for pissing off the professional community like beating them at their own game. All the people who told Elon Musk, you can't make an electric car. GM has tried, Ford has tried, BMW has tried, Mercedes-Benz has tried. It's not working. And Elon says, yes, it will. And we have an entrepreneur. So what does Percival Lowell do? He gets one of the leading camera specialists in the world, Charles Lamplin, and he says, make me a camera, develop me some film so we can take photographs of Mars. These, friends, are some of Lamplin's photographs.
That is
these
cool.
are the first photographs of Mars. And they show surface details, and you can see dark areas, light areas. You can see northern and southern polar caps. You can see polar caps changing over time. You can see distinct bands of color change. You can see linear features. And this is probably Valles Marineris right here. And we're seeing these features, and they're photographs. They're not sketches anymore. Percival Lowell publishes another book, which becomes another runaway bestseller. And I don't know what the title was, but it could have been, See, I'm Right. And he's basically saying that, yes, these features really are there. I'm seeing color change, seasonal color change, which to him and to everybody on Earth, that time nobody's been off the planet yet, seasonal color change says vegetational change. Oh, it's fall. We lose the leaves. The landscape looks different.
Mm-hmm.
And you can get photographs from an airplane. And oh my God, it does look different. And Lamplin and Lowell published these photos. And again, a lot of Lowell's names persist today. Chrysoplanisha, the Plains of Gold, Labyrinthus Noctis, the Maze of Night, and all of these different places. And so these regions, and Percival Lowell is saying, gee, the polar caps advance and recede. We're seeing vegetative changes, he says. And people are saying, well, but the atmosphere is too thin for vegetation. And Lowell's answer, of course, as we know it, don't you see vegetation in the desert? Could you take your maple tree from the Midwest and plant it in the Sahara? Would it grow? No. Are there plants that grow in oases and on the edge of the desert there? Yes. And, you know, Scott, you and I have spent many years in California.
Yeah.
California, the low desert where we were for many years, it blooms and it gets green for about 2 or 3 weeks a year, and not every year.
True.
You get some rain and you get this amazing carpet of green and wildflowers, and it's amazing. And people take these great photos. Wow, California is beautiful. And then you go there and it's nothing like, because that happens in February, 3 weeks.
It's miles and miles of scrub until
Yes.
you get to the beach.
And then it's miles of, and
Yeah.
Percival Lowell in Flagstaff is seeing the same thing in his high desert region. And so this idea, this hypothesis that Mars is the dying planet, and essentially Lowell, a lot of his critics are saying, no, no, no. Lowell dies in 1916. He leaves most of his widow spent years fighting the will. He left most of his money to the Lowell Observatory and the search for Planet X, which ultimately Clyde Tombaugh vindicates him in 1930 and discovers Pluto, which is a planet, and had to stick
Ding, ding, ding. Ding, ding, ding.
That's right, sir. And so we get this whole thing, and then of course, 1930, not H.G. Wells, but Orson Welles does the play War of the Worlds, scares the pants off everybody, and that just makes the official government university, it's not the military industrial complex, but certainly the civil academic complex is kind of like very down on this idea of Mars. And so through between 1930 and 1960, there's almost no research on Mars. There are a few. H.O. Haldane did some spectroscopy and said, yes, Mars' atmosphere is really, really thin. I don't detect water vapor. I don't detect oxygen. All I'm detecting is CO2 and maybe some nitrogen, maybe, but the atmosphere is incredibly thin. And he posits it's somewhere south of 1/10 of an atmosphere. He said it's really, really thin, maybe as low as 5%. Well, we get into the era of rocketry. It's kind of amazing. You realize that, okay, 1957, Sputnik. 1964, the United States sends a space probe to Mars. Our first successful space flight with a human being suborbital, 1961. And 3 years later, we're sending a spacecraft to Mars.
It's incredible.
We went to the moon. People are saying, oh, this is the anniversary of driving a moon buggy on the moon. And we haven't been back in 50 years. I tell people this when I see them criticizing, oh, Jeff Bezos went to space. What a jerk. He could have fed a lot of poor people with that money. You know what? If you think the government is going to get you there, it's been 50 years. We're having to reinvent the technology. We saw this in a video a couple of weeks ago, Scott. Oh,
Right.
we can learn a lot of how to drive a buggy on the moon by watching these videos, because all the people who did that are dead now.
Right.
Or they're really, really elderly. We're talking the people who went to the moon are in their 90s.
The guys that made those big engines for the Saturn V,
They're all gone.
they had the blueprints, they had everything, and they tried to build them from the blueprints. And when they did, they didn't work. Okay.
Yeah.
And it was only because of the skill and the tribal knowledge of those guys building those engines. They knew
And they
how
did it
to
with slide rules.
change the Venturis and all the rest of it, that made that engine
No
work.
computer simulations. They did it with slide rules.
Right.
And
And
so
their
in
brains.
1964, we're working with slide rules. We're sending a spacecraft to Mars. And people say, we couldn't possibly get back to the moon before 2040. It's like, we went from suborbital flight to a spacecraft around Mars in 3 years, folks. 3 years. We did it in 3 years. And we did it successfully. And we sent back, Mariner sends back photographs. And I'm going to share another picture. And this one was kind of a chance for all the scientists to say, yeah, told you so. Mariner 4 flies over the Southern Highlands of Mars. It is the highest altitude place on Mars. It has the thinnest atmosphere. It's the oldest surface on Mars, which means it is the most cratered. And we're not talking megapixel photos here. We're talking about 100 by 100 pixels, approximately. We're talking about 0.001 megapixel photo. It's really low res. It's like stupid low res. Your old school black and white TV had hundreds of times more resolution and data. And this was a very primitive camera. They got 24 photos out of the whole mission. That's it, that's all. And they had to be low res because they were basically breaking them down into ones and zeros and beaming them back and then reconstructing them. And you can see the graininess of this image. And everybody said, look at that. It's not Earth, it's like the moon. And Mariner 4 kind of gave the scientists a data point to push back against all the science popularizers who said, dying planet, but dying isn't dead. Dying Mars means there's still life there. We should go look for it. This would be significant. And the whole dying planet idea, NASA came back and said, nope, dead. Look at this. It's not like Earth. It's like the moon. It's overlapping craters. There's no evidence of anything like lakes or rivers or even riverbeds. There's nothing, nada, zilch. And we go from the dying planet idea, which is a romantic notion about Mars, which is based on, it's a public fantasy based on a handful of data points and a man who had almost a P.T. Barnum-like genius for publicity. He also had a hell of a lot of money, and he knew how to do publicity, and he was willing to invest it in outrageous projects that people said couldn't be done and say, look here, I did it. Aha, I told you so, screw you. Does this sound like Elon Musk? He's kind of the intellectual, Mr. Musk is kind of like the intellectual reincarnation of Percival Lowell. And so the scientific community in 1964 pivots from dying planet to dead planet. And we see the birth of something in the literature that's known as the dry Mars hypothesis. And this hypothesis comes in, and the basic idea is there is no water on Mars. There's basically no atmosphere. There is no water because it would all evaporate away into space. And at that point, we're able to do low pressure experiments. And we go, well, look, you put water in and Mariner, one of the things it did, they sent radio beams through the atmosphere and they confirmed we're talking a few millibars. We're talking about Mars atmosphere is about 1% to 0.5% as much as Earth. And so you take the 1,000 millibar atmosphere of Earth and you boil it down to 10 millibars and you try to put water in there and it flash evaporates. At 10 millibars, water doesn't boil, it explodes into vapor. And so Mars obviously has no water whatsoever. It's completely dry. It's like the moon, it's dead. And for all the people who ever said, oh, you should look for life on Mars, the scientists are now gleefully saying, no water, no life. The interesting thing is, Scott, they are doing the exact same thing that Percival Lowell did in the early 1900s.
That's right.
They're building an entire hypothesis. They're characterizing an entire planet based on, they don't have as much data as Lowell did. They've got 24 pictures, and most of them are really, really poor. Most of them are really poor. I mean, you know, you take a look, and if you go to the NASA website and you look at these, Scott, they've cleaned them up a lot. They've improved the resolution.
I'm sure.
But you look at the original photos, it's like, really? Is this a Rorschach test? Am I supposed to see something here? It's blurry nonsense. It's really a terrible photo. And the scientists are doing exactly the same thing as Percival Lowell. They've got basically a single data point, and they're crafting an entire hypothesis about an entire planet and its climate and its history, its geology, its biology on one data point. And they're saying to all the people who fell in love with the dying planet, no, you're wrong, it's dead already.
It's dead already.
It's dead already. When we come back next week, Scott, we're going to jump forward in time a little bit, and we're going to look at how the dry Mars idea evolves into something completely different.
Ooh, okay.
Mars, two things we know about Mars. Getting to Mars is hard. Only about half the spacecraft ever launched to Mars made it successfully. And second, you don't know Mars. Because every time we've had an idea about what's going to happen next on Mars, we found out, wait a minute, we're wrong. And we're wrong. And so next week, what we're going to look at is the dry Mars theory in more detail. So Mariner and early spacecraft, we're going to take a look at that in some more detail and see about the dry Mars theory and how there was no ESA at that time, but there certainly were European and Russian and Japanese astronomers working on this problem. And we're going to look at how they crafted an entire theory from a very small data set. Now, this isn't necessarily a terrible thing. Science moves forward like this all the time. Copernicus did this, Kepler did this, Galileo did this, Newton did this, Einstein did this. But you know what? We remember the people who write, and we tend to forget the people who were wrong. And in this case, there's a lot of whitewashing that goes on with professional space agencies today about where we've been, what our history is, and the stuff we used to say. The professional science agencies aren't always frank about, well, we used to think this, but now we think that. They tend to be, the mentality is, what have you done for me lately? That's their funding model. That's their publicity model. But we're going to kind of dig in and take a look at the dry Mars hypothesis and how it influenced exploration.
Right. Very cool. Very cool.
Hey, Daniel, question. Yes, I remember reading that that there's a pretty strong conjecture that Percival Lowell was actually drawing the shadows of the blood vessels in his eye.
I have not heard that.
I haven't heard that either. And
I will say something though. I remember one time looking through a 6-inch f9 refractor, and this was in California, and in the Meade Instruments parking lot, and we had a evening of spectacular seeing. I mean, it was, sometimes California can just get this really great seeing, probably from the laminar flow of the ocean or something. But the effect of seeing what looked like spider web-like lines on Mars. I actually saw it. Okay. And from what I understand, it is one of the I guess one of the theories about it, or one of the ideas about it, is that your mind makes shapes. Okay.
Yes.
It makes shapes, and you know, and through I forget what the process is called, but there's a name for it. And I saw this and I go, wow, okay, that's what Lowell saw, okay, and it's very convincing, okay, to see these lines.
Yeah, there's something else. You're talking about pattern recognition.
Pattern
The human
recognition.
brain is built around pattern recognition. It's a huge survival mechanism. And when there's no pattern, we tend to create them. Look at the constellations. Does anybody really look at Capricorn and see a mermaid goat? I don't, but somebody did.
Depends on how many martinis I've had.
Yeah, well, what kind of mushrooms were they eating out
I-
there on the hillsides? I don't know, but we have pattern recognition. Not only that, but your eye has cones and rods. The cones are color vision. Mars is just bright enough to activate the cones in the center of your eye. Rods tend to give you boundaries and edges. And so when you have contrasting areas, the cones tend to create, in your visual cortex, they create the idea, here's a boundary, here's an edge. And if you think about it, you're a primitive human being 75,000 years ago, and you're walking across the savannah, and there's a snake camouflaged on the sand or in amongst the leaves. And people who go on hiking today and, oh, look, it's a copperhead. Well, your cones help you pick out edge boundaries and define that as an object. It's a hardwired process in your brain. And with the high contrast features on Mars, yeah. And I've seen the spider web features.
You've seen this in
2003 when we had that spectacular opposition. I
Right.
had some nights out in the desert where I lived, and I saw you were like, holy cow, I'm channeling Percival because I'm seeing these features.
Right.
And yeah, the other thing is in moments of seeing, you realize those photographs of Mars were multiple second exposures, probably 30-second exposures. And when you're looking through the atmosphere, that time when everything lines up and the image sharpens momentarily for a few seconds, and you get this visual impression, and then it goes away. And now you start, oh, I'm remembering what I saw. And
Yeah.
the brain imposes order. It does.
So I found a story from using planets, so not the most maybe reputable science place on Earth. It talks about that he had his telescope stopped down so much that he effectively created an ophthalmoscope, which astronomers use to look into the eye, and the exit pupil was so small that effectively he was seeing his.
The
I have
canals in his blood
problems
vessels.
with that one, but
I'm just saying that. I knew I'd read it somewhere.
yeah, no, I have problems with that somewhere. I
I'd
don't
like to
think
see that whole.
yeah, I still don't see how you get the image of
repeated.
your retina on your retina.
Yeah.
It's the blood vessels in front of you, right? And you're seeing the shadows, is what this says.
Yeah.
Now,
I'm going to do some more research.
If you look up at the sky, you can see floaters in your eyes.
Yes.
And if you relax, you can see things running through your blood vessels in your eye. I've seen it, but
And you both,
I don't
you
think
both
would-
have seen, you
I don't
both
think-
say you've seen
I wouldn't
spider
make the
webs.
connection with Mars.
You both have said you've seen spider webs.
Linear features, yes.
Absolutely,
edge details.
absolutely. And I think that the effect is probably more along the lines of what Daniel's describing, because it is the only time I've seen that, and I've seen spectacular views of Mars through telescopes during the great opposition that we all got to see. I got to use the 60-inch at Mount Wilson,
Right.
and then I got to use the 60-inch at Palomar, and then I got to use Percival Lowell's 24-inch refractor. Okay.
I got to use the 12-inch refractor, Zeiss refractor at Griffith. And look
Okay.
at Mars.
Okay.
All right. So my best views, of course, were from California. We had arc second or sub-arc second seeing from Mount Wilson and Palomar, and you could see, clouds. It was amazing.
Stunning.
I did not see what I thought were channels or canals. Okay.
Okay. July 2003, William Sheehan in Sky and Telescope.
Mhm.
I knew I'd remembered reading it in Sky and Telescope.
Talks about the blood vessel.
Percival Lowell's name is synonymous with canals on Mars, but is reported in the July issue of Sky and Telescope. Generally dismissed as illusion. Now there's a new theory independently suggests that several astute readers of Sky and Telescope found that the markings on Venus showed up best when the instrument was stopped down to 3 inches. With that set up, Lowell shrank the telescope to a diameter of pinhole. The retired optometrist notes the setup simulates what is used in his practice, that he was seeing capable of casting shadows of blood vessels and floaters in the vitreous body on the retina. Instead of mapping the surface of Venus, Lowell would have been mapping the structures of his eye.
I have a really hard time accepting that hypothesis. Lowell, for all of his showmanship, was a very good observer. And none of these people who are talking about ophthalmic shadows have ever tried to sketch Mars in high seeing, best seeing conditions where the image sharpens for a few seconds and then it goes away. And sketching in those circumstances is extraordinarily challenging. And I think what you're getting is more psychological pattern recognition. And I see something and I've got to record it. And you realize that in spite of the fact of being drawn at the eyepiece, seeing like that is momentary, and you're drawing those pictures from memory.
And you're trying hard to make patterns. We all do it.
Yes.
That's right. All the time.
Yes, you are.
Right.
I think it's more psychology than ophthalmology, but that's a question we'll never answer. But I'm very unwilling to denigrate Lowell's accomplishments because they were substantial and profound.
That's true. That's true.
And we think about Carl Sagan. How many people, and Neil deGrasse Tyson, how many people know of those scientists' actual academic achievements versus their science popularizing achievements?
Right.
Nobody criticizes Sagan or deGrasse Tyson for their creative use of analogy and metaphor. They celebrate them as science popularizers who stimulate interest. Lowell did that first, and he did it better.
I think probably academia back in those days was different than academia today.
Very much so.
Research and
Much smaller club.
and how science was conducted and who could conduct it. Okay.
Yes, it was a very exclusive club.
Very exclusive. So that I think that we have to give giant credit to Lowell for busting through that. And he certainly had one of the world's largest telescopes at his time.
He did.
He hired who he wanted to hire. He did what he wanted to do, and so probably was not, met with a lot of opposition.
He did.
From the
Did
staid, dyed-in-the-wool academic researchers of his day.
Nobody likes to be upshown in their own area of expertise. Not by another professional, and sure as heck not by an amateur.
Not by an amateur. Right.
And
that's right. But leave it to amateurs to bust through all that, right? So
certainly, absolutely. The Wright brothers were amateurs. Galileo was an amateur. Elon Musk's an amateur. Edison, well, he was a professional most of his life. Tesla was an amateur. So yeah, I think there's still a tendency today for people in the professional community, thumbs down on Lowell. But I think nobody does that to Carl Sagan, rest him, or Neil deGrasse Tyson. And I don't think we should do that to Lowell either. I think we should celebrate his achievement and his popularizing of science, which was a tremendous achievement. Do we have any quick questions before we go, Scott, from our listeners?
Well, let me look at our
because I know we're running over. And I have to ask, while you're looking at that, I will ask our question. We're having a giveaway this week. So
that's right.
There's a question, friends. There is a question. So Giovanni Schiaparelli, or Schiaparelli, as I've heard it also said. Gio, my pal Gio, he is famous for having discovered what we now refer to as canals on Mars. But of course, his original work was in Italian and he didn't say canals. So your question, friends, what term did Schiaparelli actually use and what does it really mean? Email your answer in as a contest answer, and I'm sure lots of people will, because our viewers are really bright. Our viewers will get it, and I'm sure we'll pick a random choice from all the correct answers. So go ahead and dial.
There we go. I'm putting in the email where you send in that answer.
There you go.
Okay, so let's look through the chats here.
I've got to take off. Bye, everybody. Got to meet my wife.
Thanks,
so
Ken.
everybody have a great week.
Appreciate you having me as a guest this week.
Hey, see you, Daniel. Bye.
Bye. Let's see. Well, I think just talking about the planets inspired some people.
Good.
You know, Saturn is at opposition today.
Yes, Saturn and Jupiter.
Right, and the moon right now is at its furthest point, apogee at this point today. So let's see. But Harold Locke says he's going to get his 5-inch out and get a decent photo of Saturn and Jupiter with moons. They both should be perfectly placed for my available observing time. Let's see. Amanda Zagata says, really hoping the weather cooperates. I need more video to practice my stacking. Okay.
Yes.
Yeah.
And we'd love to see some of those images too. If you
absolutely
get some good images, send them in. You can send them to me, astronomyforeducators@gmail.com, or you can email. Do we have an official email for the show?
For this show?
I don't know.
To go straight to you? No, I mean, if it's questions about
they can email me.
Programs in general, it would be explorealliance@explorescientific.com.
There you go.
But certainly, if you want questions to go directly to you, you can do that. Yeah. Let's see. We have. Actually, it's nice. We have some people I have not seen for a long time come back and watch this show.
New viewers and old folks returning. I love that.
Yeah, it's cool.
I appreciate all the viewers. I really do.
The Texas Backyard Astronomy, Glen Rose, Texas. Not sure which person that is in particular, but I've been to Glen Rose, and it's beautiful. He says, I'm looking forward to the upcoming new moon this weekend. Harold Locke says there's a reason a solo full moon is being called blue. Have to shade it with a neat tint. Okay.
There you go.
That's right. And let's see. Tarek in UAE was asking questions about Saturn.
Okay.
Mike Wiesner is watching. Cameron Gillis is watching. Space Time with Robert, he's watching.
Yeah, we're going to be doing some programs on Saturn after we're done with our Mars series, Scott.
Oh, yeah.
And my students, I'm starting classes in a couple of weeks here, and my Astronomy for Educators program, my students are going to be out looking at Jupiter, looking at Saturn. And one of the things we do is I teach a method called box and rectangle for sketching Saturn. So
Oh.
we'll be sure to feature that on a program
Very cool.
one of the weeks here, and you'll have an opportunity to learn how to make this. I take nothing away from the photographers with the stacking, but I love, there's something intimate and personal and old school about sitting at the eyepiece, personally receiving the photons in your eye from a billion miles away, and
Yes.
making a sketch and kind of communing with people like Schiaparelli and Lowell and heavens, Galileo and Huygens, and making this personal experience, a personal document. I love astrophotography, but it's a little less of a personal event for me. So we're going to share sketching Saturn, and I think everybody will like that.
Very cool. Let's see. Looking for comments relating directly to the show. Of course, everybody here is friends, so they are chatting
Chatting with each
amongst
other.
themselves.
I noticed that
saying
when
hello to
I go through
you.
the comments after the show. It's like
They're saying
friends are chatting at the table. And I think that makes this a wonderful community. I
Yeah.
love that. And I see new people come in and they're welcomed by folks who have been here. Glad to meet you. The great show. Oh, you're going to have so much fun. And can't tell you how much that stuff just puts me over the moon. Just thrills me that we've got a community here.
Right. And a worldwide audience. We had people watching from the Philippines. We had people watching from United Arab Emirates. We have people watching from England. So
That's great.
which
And
is
if
kinda
we,
cool.
again, if we
Yeah.
have,
And Germany. That's right. I forgot
Hey!
about Wolfgang here.
if we have folks,
Wolfgang, who goes by, has the handle of Ula Drake.
there you go.
It's been many months since I've seen him back on our show, so it's cool to see you.
Good to see you.
Of course, Beatrice is on, Jeff Wise is on, Andrew Corkill, Wade Prunty, Book Davies, many of our
Our regular crew.
longtime loyal audiences here. There was a question: any chance Earth would look similar to the moon if the water and force were removed?
Yeah, if you remember, Mars has been dry for more than 1 billion years. And if you took the water away from Earth and gave it 1 billion years of weathering, especially if we're assuming our same atmosphere, we'd still have terrific cyclonic storms, but we wouldn't have the rain. And the surface dries, it powders, and it becomes an abrasive mess. And this sandblasting effect that has weathered features on Mars. And that ties in with the color changing, and we'll talk about that next week. But yes, we would have a very dry. And what would be interesting is you could have an elevation change on Earth of almost 20 kilometers from the highest peaks to the lowest trenches. They would all be dry too. And we found out there's some similar things on Mars, but no spoilers. I'm not gonna.
That's true. You're going to talk about these in future programs.
That's right.
So that's cool.
Well, this is great. And,
all right.
I'm so thrilled, and I want to say thank you to our audience. And if you have questions, please email me. If you know a teacher who's trying to do astronomy and space science with kids at any level, give them my email. I'd be happy to reach out with them and help them improve their program and share materials. And until next week, friends, I'm hoping you will have clear skies and nice nights. Take advantage of Jupiter and Saturn over the next month or so, as well as the dark skies. So thank you to everybody, and we'll see you next week.
Take care.
When you go to another planet, there's just so much potential for making brand new discoveries. My name is Katie Stack Morgan, and I study rocks on other planets. So Mars 2020 will be seeking signs of ancient life in the rock record of Mars. The instruments are really well suited to look for things that we call biosignatures, which are signs that ancient life might have been there in the past. To really confirm that life had a hand in creating those signatures or textures, we really do need to bring those samples back. We have capabilities in laboratories here on Earth that we can't fit in a compact instrument on a rover. This is the Mars Yard, and this is where our rovers practice driving over rocky terrain. We work together with the engineers to understand what type of terrain the rover can handle so that we can get to the most exciting places, which are often the most challenging. So our landing site for Mars 2020 is Jezero Crater. What's really exciting about Jezero is that it has a beautifully preserved delta. They tend to be a really good place to preserve evidence of past life. And we look for things like organic matter that get concentrated in the rocks of a delta. So this rock is a sandstone, not unlike a rock that we might actually find in Jezero Crater. We would be interested in sampling a rock like this to understand what each individual sand grain has to tell us about Mars and its evolution. Growing up as a kid, we used to go on lots of hikes and would visit national parks for summer vacations. So when I found out that I had the opportunity to combine geology and love of the outdoors with exploring rocks on another planet, I thought, this is really the perfect type of thing for me to do. Not only could I work on an interesting science project, but I could do it with a big team of people all working together with a focused goal. And I thought, that's what I want to do.